Hey, I'm actually swapping PowerPoints now. Sorry about my timer going off on the other one, but the other PowerPoint actually did a better job when it explained them in. But now I'm switching to your PowerPoint that follows your book to go over the parts of the cell and the cell membrane. So the plasma membrane, we've talked about it before, is the thin, flexible boundary between the cell and its environment. Its job is to let certain things in and allow certain things out. One of the things that needs to come into your cell is going to be nutrients. We need water to flow in and out. We need certain elements to come in and out. Sodium and potassium are two of those that are very important. Also, certain cells are going to need certain things that maybe other cells don't need. For instance, your bone cells are going to let in a lot of calcium, but they're not going to let in um, iron, for instance. Iron is something that our red blood cells are going to take up. So each cell is going to be different, and the needs of that cell is going to be different. At the same time, oxygen needs to come across the cell membrane because oxygen needs to be carried to every one of our cells. And of course, the waste of the cell, which is mostly CO2, carbon dioxide, is going to have to leave. So this bilayer, this phospholipid bilayer, its job is to allow nutrients in and to allow waste to leave. Now, the plasma membrane controls the movement in and out, but it is very, very selective. Selective permeability is the way we describe the cell membrane because it's very picky. That's what selective means. And permeable means that it can pass through. So it controls the amount of substance coming in, and it's going to control the amount of substance coming out. Now, these little round figures here and this middle, this is your phospholipid bilayer. So we've talked about this before, but it's really important to remember that there is a lipid bilayer, and it's a phospholipid because there's a phosphorus group attached to the head, which makes this head portion polar or hydrophilic. The tails turn inwards. These are the fatty acid chains that we talked about when we talked about lipids, and they're hydrophobic, which means they're water-fearing. They don't allow water in. All of these structures that you see here that are coming out of the cell membrane are proteins that are embedded in the membrane that actually help the passage of other substances that are too big to slip through the cracks. The only three things that can just slip through the cracks of this membrane is oxygen, CO2, and water. Everything else is going to have to come by means of one of these proteins, which is commonly called a channel. I will test you on that, guys. The three things that are small enough to slip through this cell membrane are oxygen, CO2, and water. Your cell is in water all the time. So by osmosis, water is going to flow in and it's going to flow out. Oxygen and CO2, when you breathe in and oxygen attaches to your red blood cell, your red blood cell takes the oxygen to the rest of your cells, and they are going to be able, the oxygen molecule can slip through and the CO2 can slip out. This occurs in the capillary, and this is really important. It is called gas exchange. So when we refer to gas exchange of our cell membrane, we are referring to carbon dioxide going out and oxygen coming in.